Hi, welcome back to CMG-MathSpace. This is your space for learning core math and elective math for SHS students. So we are dealing with chapter 2 of the AKI-OLA core math series for SHS students. And then with a standard form, we got to where we are dealing with addition and subtraction. We couldn't finish, and I would like to touch on that before we go on to multiplication and division if time permits. So here we got to this particular point where we had the solution to be 0.9 times 10 raised to the power -4. Now a caution again is that don't watch these videos concerning standard forms if you haven't done approximation of decimal places and there's significant figures. You wouldn't understand if you should jump to this place. So once again, we got to this example having 0.9 times 10 raised to the power -4. And we said this is not in standard form. Why? Because there is a rule where we learned beforehand that a times 10 raised to the power 10 negative 10 raised to the power n, right? And a should be greater than or less than 1, and at the same time less than 10. So having 0.9 times 10 raised to the power 4 is not in standard form. So we have to take it back to what? Standard form. We have to find a way to take it back to standard form. So here, this is what we do. So this particular answer, which is 0.9, can once again be expressed in standard form by having 9 times 10 raised to the power -1. Why is it so? The 0 is here, which is not. So we have to take it to significant figure, right? So it should be here rather, behind 9. So we have something like 9.0. 9.0, we didn't bring the 0. So 9.0 times 10 raised to the power -1. Why is it negative? It's because it was introduced here, and now we are moving it back to where it's supposed to be, right? So that is why it's that. So having this, now we have this again. So now what do you do? Having the same, we can actually go on applying the law of indices, and then we can do this. That's be addition of the what? The powers. So that is why it is here, right? So let's go on with more examples so that you'll be very conversant with that. I don't want to make things too obscured. So let's move on to this particular one where we have evaluate giving your answer in standard form without using the calculator. So like I said, make sure that we have the powers of 10 the same. If not, you have to do a calculation before you send them back to the standard form. So in the same way, we are saying that first express each number in full. So 2.8, right, times 10 raised to the power -4, actually +4. So this is expressed as what? 28,000 with this number of index. So you move what? How many times? Let me bring it once again. We have this. The dot is here. You're moving how many steps? 4. 1, 2, 3, 4. So meaning bringing your zeros. Bringing your zeros. Bringing your zeros. How many threes? How many zeros? Sorry, it's 3. Hence 28,000. I think you are getting the picture. I want you to understand this. So from there, we have this. The same thing is applicable to 1.6. So you do the same thing. After that, this is what we have. Now having this, you are not done because we are solving or doing this in standard form. So after having this answer, you take it back to standard form, which will be 2.96 times 10 raised to the power 4. I hope by now you should understand why it is so. I can't be saying the same thing all the time, right? So the same thing is here. 2.5 times 10 raised to the power -10. We take it back, right? Let me show you this. Is 2.5, and then the power is actually -4. So even -4, we are moving to what? To the left side. That is why it's so. So put it down. 2.5 negative, moving to the left side. So 1, 2, 3, 4. Right? Then dot will come. So that is it. That is why it's 4 here. So at the end of the show, you should make sure you have the number of zeros to be equal to this power. So So hence 1, 2, 3, 4. The same thing applicable to 1.6 times 10 raised to the power negative 5. You do the same thing. How many zeros? 5. So 1, 2, 3, 4, 5. Because it's negative 5. That's why we are moving to the left. So after doing that, this is what you have, right? So you do your subtraction. Then after doing the subtraction, you take it back to standard form. I hope by now you have understood the whole idea. Good. So now let's go back to our multiplication and division. Quick. Great. So we are finally on multiplication and division of numbers in standard form. Now, real quickly, the rules is that for multiplication and divisions, we do grouping and we apply the law of indices. Now, don't be alarmed. We choose the simplest one of the laws. We have a number of them, but this one is with the addition and subtraction of the powers, right? When it is multiplication and then when it is what division, right? So here, just listen attentively. So we are saying that multiplication and divisions are sometimes easier to do in standard form. To do this, we use the law of indices. Don't worry, take extra care when there are negative indices of 10, right, in the calculation. So now, without using calculator, work out this. We have 9.3 times 10 raised to the power 5, all in one. Then all in one bracket times 2 times 10 raised to the power 3. So what you do, like I said, we do groupings first. So groupings is that we group the A part of the expression. I showed you how standard form are expressed. I don't want to be using whole numbers or integers. It will confuse you. So that's why I'm saying that we are using the A aspect of the expression, right? A times 10 raised to the power raised to the power n. So that's what I mean. So we are grouping the A aspect first, which is what 9.3 times 2, all in one bracket, times 10 raised to the power 5, 10 raised to the power 3. So working out multiplications, what we have. So now we are multiplying this and this, which will give us 18.6. With that one side, we multiply that by 10 raised to the power this and this. Now in indices, when we are multiplying numbers of the same index, we add the index or the indices. So we have 5 here, you have 3 here, you add it. That will be 8. So it's 18.6 times 10 raised to the power 8. Now that is not all, because this is not in standard form, right? This is not in standard form. Standard form should always make sure that the A aspect is less than 1 or equal to what? 1 or less than 10. So greater than or equal to 1 and less than 10. 18.6 is more than 10. So we have to express it again. So now introduce the 1, the decimal point between the first and second significant figures. So hence we have 1.86 times this, right? This is expressed again. You understand why it is. So now I'm not going to worry myself explaining every step because I know you know. So now this is what we have. It's 10 to the power 1, because from here we move to here. It's one step and move to the right direction. That is why it's 1. So it's the same as that. It's as simple as that. So now we have what? 1.686 times 10 raised to the power 9, because we added this and this. It's as simple as that. So the same thing. Now let's look at now. So we have basically done the multiplication, right? So let's deal with division, right? The division aspect of that. So division, the same groupings of the A aspect, this and this. Now we divide this. We have 0.8 times 10. This is that. Now we have you subtract what with division. We subtract the indices, the exponents, actually the same words. So we have 4. Now this is less than what? It's less than 1. So what do? We have to do something again by changing this back. So you have this times 10 raised to the power negative 1 and that. So what do? So use the laws of what? Indices, and then we will have this on your screen. So thank you very much for watching. We will see you in the next one. Ciao for now.